Hello everyone, Miss Meek here, and today we are going to talk about combining like terms. So this is something that we can do with expressions to simplify them. So it's another way to write an equivalent expression in a different way, and it also kind of simplifies them. So let's go ahead and talk about how does this work. When I am adding or subtracting in an expression, we have to pay attention to the different variables being used. So if I have the same variable or a like term, okay, I can add or subtract those things together. So if I had a bunch of Jolly Ranchers in one hand and another bunch of Jolly Ranchers in another hand, I could put them all together and have one big pile of Jolly Ranchers. If I had Jolly Ranchers in one hand and then a handful of M&Ms, I probably wouldn't want to combine them all together because you have fruit candy and you have chocolate candy. They are two different things. And our variables are like that as well. They like to be combined together with the same variable, and they like to be kept separate from variables that are not the same as them when we are talking about addition and subtraction. So if we take a look here at number 1, let's use colors to represent our different variables. So as I look here, I see I have some X's. And I look and I have some more X's here. So because both of those variables are the same, they're just an X, I can combine all of those X's together. So I have a grand total of 10X. Now take a look at your other numbers here. I have a plus 2 and I have a minus 1. So I can combine those together as well because they're just numbers. They don't have any letters or variables attached to them. They are the same thing. And so what I end up having is 2 minus 1. So that's going to be 2 minus 1 is 1. So I have plus 1 more. And I cannot combine this guy with this guy because they are two different things. This 1 does not have an X on it. The 10 does. And so they are two different types of candies. They are two different types of numbers. One has a variable attached to it. The other does not. And so this right here is as simplified as my expression can get. Let's take a look at another one, number 2 here. So it looks like I have a couple different variables going on. Not only do I have a 2x, and again, when I look at these, I want to also look at the sign before them. So like even up here on number 1, this 7x was a plus 7x. So that means I was adding 7x. Here I'm adding 2x, okay? But I don't actually see any other x's. So I may not be able to add that 2x to anything. I do see a 4y, and I do see a plus 4y. Now, excuse me, y and y, same variable there, so I can add all of my y's together. That's going to be a grand total of 12y. Now, I don't have any other y's. I don't have any other x's. So that x, those two x's, that's all there is. And then if you look at the very end, I have a plus 3, and there are no other numbers without variables. So I can't add that plus 3 to anything. And so my final simplified expression is going to be 12y plus 2x plus 3. And again, I cannot add those y's to the x's because those are two different letters, like two different types of candy. We don't want to combine them together. And I cannot add these numbers with variables here because this 3 does not have a variable, so I can't add anything together. Addition and subtraction likes to keep everything separate. They don't like to combine things together. Now, though, multiplication is a different story. If we take a look here at number 3, we're multiplying 5 times 3b times 2. Multiplication doesn't care about anything. Multiplication doesn't care if you have numbers or letters or anything. Multiplication just wants to multiply everything together. It wants to smush everything together. And so here on number 3, because I have these multiplication signs, everything is going to be combined together. So we're going to start off by multiplying 5 times 3b. That's going to be 15b. And then don't forget you have times 2. So 15b times 2 is a grand total of 30 b's there. So 30 b's. Multiplication does not care. Multiplication will stick together whatever it wants. Addition and subtraction likes to keep things separated out. Multiplication will just combine everything together. So let's take a look at number 4. We have some addition that's going to keep something separate, but I do see a little multiplication problem I need to take care of before we get started here. This is 4 times 2y. Now, when I multiply with variables, it's the same thing as normal multiplication. You just stick that variable on the end. So 4 times 2 is 8, and it's going to be 8y's now. So plus 7 plus 10x. So here's our new expression that we need to kind of simplify and combine some things together. First of all, I see I have 3x. If I go on down, I also see I have plus 10x. That is a grand total of 13x's that I can add together. I see I have a plus 8y, and I don't see any other y. So that's just going to stay the way it is. And then I also see a plus 7. And again, there are no other numbers without variables, so that is going to stay alone by itself as well. And so my grand finale, my grand finished expression is going to be 13x plus 8y plus 7. I have added together all the things that I can add together. I did do a little bit of multiplication right here with these y's, and that's fine. Multiplication sticks everything together, and then addition keeps everything else separate. So that is why I cannot add my x's to my y's. I cannot add those numbers to my to that 7 on the end that doesn't have a variable. Let's look at a couple more examples here. On this one, do we recognize this? This is the distributive property. So that means that we have some multiplication to take care of. The distributive property means that I am going to multiply 4 times x plus I am going to multiply 4 times the 3. So when I simplify that, it's 4x plus 12 minus 7 plus 6x. So let's see what we can combine together. I see I have 4x, and I see that I have a plus 6x, so I can add those together for a grand total of 10x. I see here I have a plus 12, and I see that I have a minus 7. So when I combine those together, that's subtraction. 12 minus 7 there, which is 5, and it is a positive 5. So my simplified expression is going to be 10x plus 5. I've combined together everything that I can combine together for the time being. All right, let's take a look at this last one here. I see I have some y's, so 6y. Any more y's? Oh, minus 4y. So 6y minus 4y means that I'm going to have 2 y's left over. So the way that I like to think about it is this 6y is literally 6 y's being added together here. And then down here, we have 4 y's being added together. So what we're doing is we are going to end up subtracting 4 of these y's from the 6 y's, and that's why we have the 2 y's left over. So that's how I got that subtraction there. I have some x's here. I have a subtracting 3x, so minus 3x. Plus 10x. So again, that's going to be 10x minus 3x's for a grand total of 7x's, and it is going to be positive, so there's some subtraction there. And then the last one I have is a plus 2d, and I don't have any other d's. So that number I can't add to anything else. So my final simplified expression is going to be that 2y plus the 7x plus 2d. So I have combined together everything that I can combine together, but I have still kept separate my y's and my x's and the d's here for this one. All right, I hope that this helps clear up any confusion when it comes to combining like terms. Remember, addition and subtraction wants to keep separate all of the letters. Multiplication doesn't care. Combine it all together. He does not care at all. But the whole idea is, again, to write another equivalent expression of something else. So that's what this chapter is all about. All right, I'll talk to you later. Bye.